Hi there, I'm Deep Dylan. Welcome to your AI Injection, the podcast where we discuss state-of-the-art techniques in artificial intelligence with a focus on how these capabilities are used to transform organizations, making them more efficient, impactful, and successful. Welcome back to your AI Injection. This week, we'll be discussing how AI can transform unstructured enterprise data into valuable insights with Slater Victoroff. Slater is the founder and CTO of Indico, an enterprise AI solution for unstructured content with a focus on document understanding and process automation. He has years of experience in building AI and deep learning solutions and even made it onto the Forbes 30 under 30 list. Slater, tell us a little bit about yourself. Why did you start Indico? And what is it about Indico that you think is really speaking to our times right now?
Three great questions. Maybe let me start. I'm Slater Victoroff. I am the CTO and founder of Indico. So that's somewhat relevant. I'm also an EIR at 406 Ventures. And for folks that don't necessarily know what an EIR is, that's an executive in residence, which means that I spend a lot of time doing technical due diligence on companies. So that's another little bit of perspective. As far as why I created Indico, I think the simplest I can tell this story is around one quote that I told to a professor of mine in 2012. That I sometimes say is the most wrong I've ever been. And I said to her, the war is over, deep learning lost. I was completely certain of this as, a sophomore and undergraduate who had a couple of early successes. What year was this? 2012, which is important, which is very important, right?
Okay.
Because in 2012, right, that wasn't a strange position to have, right? I mean, in 2012, that was basically the majority position in AI. But AlexNet 2012 was the year that everything changed.
Yes.
So very, very roughly, I was doing Kaggle competitions with a friend of mine, and I realized that I was completely wrong about deep learning. And Indico started as this goal to really figure out what we could do to make this incredible technology accessible. Right. And that was the question, that was the problem that we saw as kind of the kernel of this. Things change, right? We've been at this for 8-9 years. The world is a very, very different place from back then, when we were writing our own CUDA code and, hand modifying Fortran 77 to get our stuff to run, right? And so really what Indico has settled on today, we've got three big technical pillars, but really before that, what I like to say is our philosophy is bionic arms, not androids. And that's because the position that we fill is very much trying to be this connective tissue, both of the organization, but very specifically between humans and AI. And we work in the document processing space and working in really all manner of unstructured data. So document processing is like super, super hot, but you can also imagine anything that is image or text where it kind of falls under that very broad umbrella.
Yeah, I mean, that was a question I had for you is like, just kind of like perusing your website and looking at some of the background info. We handle all unstructured data. As you know, that's a kind of a pretty general world. There's
totally.
So what specific areas do you focus on? I see a lot of like RPA related stuff in there. So like process automation work. Is it really like the kinds of docs that you encounter in the enterprise that you're focused on and the types of imagery that you might encounter in an enterprise context, or is it something else?
It's a really, really good question. And I think the reason that we make this claim is because we've got a really different model from what I think a lot of people would assume. So we don't, for instance, do what is the predominant way of doing things, which is say, hey, there's this very specific, like mining 10 Qs, right? And we're going to create a model that does mining 10 Qs and we're going to release that. We don't do that. What we instead do is we have a platform, right? And a product really, that we provide to customers that allows them to build their own models so quickly and so easily that they don't need to go and spend a huge amount of time kind of vetting something externally. So we will integrate with folks. If you've got something that's a particularly good model for a particular domain, you'll have that in the platform. But really, when I say sort of the connective tissue, it's all of that staggered loop learning and the human in the loop stuff, the connections to upstream and downstream systems. Process automation is a great example of where things do get a bit complex. We might connect with RPA maybe upstream and downstream, but unstructured processes have their own unique complexities to it.
Do you have labeling capabilities and annotation labeling? And do you help companies like handle a workforce of labelers? And do you facilitate that across the entire spectrum of things that you might label within images, like segments, image level labeling, and temporal segments even, and
so we're much more kind of language and document centric, right? So things like temporal segments, right? We're not very deep on video. We're not very deep on time series for things along those lines. But other than that, right? You've absolutely got the characterization, and I think it's very interesting the way you talk about it's like, oh, it's a labeling tool, and I think that's a really data scientist centric way of thinking about the world. I think it's very, very fair, but I think that one of the things that we really have realized is that what in one pane looks like a labeling tool, kind of the function that has to play within the organization actually gets much, much deeper than that, right? So you think about the things that you actually have to offer to effectively get you from I have a problem to I've got something in production that is going to like effectively learn continuously and have a change management process, right? And all that.
Let me see if I can guess a little bit further then. So
yeah.
In addition to facilitating labeling of a particular problem, with more of a focus on the kinds of stuff you would encounter in the enterprise, you also facilitate the construction of models, maybe even the parameter optimization, the hypertuning of models, the deploying, the runtime inference of the models as well.
Certainly all of that.
Okay.
Explainability is really, really key. I think one of the things that's important also is that this is not kind of exclusively a tool built for the data scientist. This is something that is really, actually Gartner has a new term for this that I absolutely love, multi-persona data science platforms. And that's what it is, right? Because actually it's not like this is for the data scientist and then, a subject matter expert comes in and labels some data. It's like, it's just as much for the subject matter expert that is processing the contracts day to day as it is for the data scientist. So we kind of view those as two equal users, and that's why I would say in practice, it's not really that they've got like a team of labelers, right? Because labeling is never the goal. Labeling is usually just some like weird side process that you have to do because your stuff is messed up. So instead, it's like we plug into the production process just the way that it works today. Subject matter expert can use the thing even before any AI is turned on at all, right? But then the data scientist also doesn't have to go through all that hassle of like, oh, I've got to find some data and I've got to do some separate labels and all that. They're actually like right there in the stream that the subject matter expert is sending along. Like they've got metrics, they've got models automatically tuning on that. And then, yes, you've got all the things that you also talked about, but a really rich set of explainability tools that facilitate that conversation between the subject matter expert and the data scientist to help really get the problem framing right. Because it turns out that is really the hardest problem in practice.
So maybe walk me through that a little bit. Like,
yeah.
What does that mean to facilitate the problem framing from a practical standpoint?
Yeah, so usually what happens, and I'll use a really specific example. Let's say you've got some insurance company and they've got insurance policies. Over the years, they've come out with different insurance products that are going to be, different in maybe significant ways. Maybe they've got life insurance and health insurance and, like ice cream truck insurance. Or, maybe these are more marginal things like, oh, there's the silver 2007 life insurance policy and like the gold 2018 life insurance policy, but you can only get that one in Connecticut, stuff like that. Mm-hmm. So they've got this huge kind of sea of stuff and they want some structured information on top of that. Now, in the data scientist world, right, the problem hasn't necessarily started yet because they actually really need to figure out that very critical piece of what structure do they want to put on top of these documents.
Yeah, and that's where the interesting conversations start, right? Like that's what we do all day long. We're a custom machine learning AI shop. That's where it gets interesting, right? It's like, right. What do you actually need? Why do you think you need that? Let's validate whether that really matters if we build that, like all those sorts of questions.
Right. And what we find is like a really, really helpful thing. It's all about accelerating the rate at which you can do those experiments. We find the non-technical person has to be able to be like, I think this is the right schema and try it and label a couple documents and have, and maybe this is not the perfect model they'll ultimately end up with, but some very kind of rapid feedback to let them know like, hey, is this kind of working? Is this not? Where is this running into problems?
So like rapid, early, quick labeling, propagation of those early, let's call them mediocre models at the beginning against the back corpora, and then active learning driven corrections of mistakes, something like that?
Something like that. What I would say is like the active. So we do have. I shy slightly away from the active learning term, not because it's not wholly accurate, but just because I think that usually means like pure statistical active learning, and for us, it is very much a human-driven process, and I think that is an important distinction. So there is a process of like I've got the schema totally right, and I'm labeling things correctly.
Human-driven in the sense that you may not yet have the labels correctly defined. The label universe is still evolving.
That's a huge part of it. Yes.
Okay.
Yeah.
And then
in fact, that's the first 80% of the process, I'd say.
So your label universe definition, you want to basically kind of quickly facilitate this. Now, your text pieces is that operating at the document level, the sentence level? Are they text spans? Is it categorization, or is it all of the basic stuff for natural language?
All of the above and some more. So I would say spans are kind of the truest answer to that, but we do have a really true multimodal fusion system on the back end here, which says like we handle things at the document level. So, it can be anything from a totally raw image to just pure text with no image information. And it kind of handles that seamlessly and can kind of leverage the relative information across that spectrum.
And then do you have like hooks into like the Turk and all kinds of places where you can like leverage crowds of labeling? Or
here's the thing that ends up being really interesting. You need very, very little data to do it. So we find actually that people usually are either in a production state or very close to it by the time they've done 200 examples. And which is actually not that crazy if you're kind of like staying up with some of this modern stuff and people are doing 0 and 1-shot learning and things along those lines. It's like, okay, that is believable. But I think one of the things that is really, really cool about that is that it means that you don't really need to do this kind of large scale data labeling anymore. It's like 200 examples is kind of what it takes to get to a consistent problem definition.
Sort of, if you have the right 200.
Well, that's the key, right? It's not any 200. It's almost never 200 of like a database dump that they've got. In 99% of cases, right, they end up having to make the 200 from scratch because the existing data is just not usable from some way or another.
Yeah, I mean, that's sort of the reality of these sorts of things, right? Like, you start labeling, you have to think about what to label. So you get an idea, you start grabbing like recipes, and now you're labeling ingredients or something. Right, you're going to get all the usual ingredients, but are you going to get to nettles and like just kind of weird esoteric stuff? Maybe not right away. So
I'll give you actually maybe a slightly better example, like with recipes, right?
Okay.
So the issue you run into is like, oh, well, we've been processing recipes for 40 years. These are the things you pull out of a recipe. And you're like, oh, what? And field 5 is like the hair color of the chef. What? Like that's not in the recipe anywhere. And they're like, oh yeah, no, we Google that as a part of our process. And you're like, oh, wait a minute. And then maybe there's another field that's like overall weight of the recipe, right? And you're like, oh, wait a minute, like that also clearly doesn't appear anywhere on the recipe. They're like, oh yeah, well, no, I kind of like pull these numbers out, which I don't track anywhere, and then I kind of add them up. So that's a lot of what it ends up being.
So you're speaking to the corpora itself. That content inside there may not represent what actually the business goal is or the thing trying to be.
It represents the business goal. It does not represent something that is ready for use by a machine learning process, right?
Mm-hmm.
Because even though what they're doing is often close to extraction or close to classification, it is never that exactly. And it's never the case that their historic data is like so close to that ML task that you can use it as is. And that, I mean, it is an unfortunate reality. We often have to show up at customers and be like, sorry, I know you've been doing this for 40 years. I know you think this data is like super valuable. You've not been tracking it in the right way.
Well, that's a good point. And it's sort of like, maybe taking it out from your system in particular into a kind of a general machine learning space. But one thing that we find is there's a difference between labeling things for the, I don't know what to call it, but like the human playbook of whatever's been going on for a while. There's a very big difference between that and human labeling of data to feed into models, algorithms that are going to learn from it. And one of the things that we find is that, like however humans have been doing something, humans have like less specific labeling requirements, if you will, because we've got brains
they're inconsistent,
kind of fill in the gaps, and we can ask people and things can happen out of bandwidth. And whereas machines have a very specific way of giving them examples. Hi there, I'm Deep Dillon. Welcome to your AI Injection, the podcast where we discuss state-of-the-art techniques in artificial intelligence with a focus on how these capabilities are used to transform organizations, making them more efficient, impactful, and successful. I mean, that was like a question I kind of had for you. Like, do you run across scenario? Like, so one of the things that happens a lot is somebody has a product, the product does a thing, it's got an audience. The audience is sort of available for labeling in a sense. That's not their main goal. Like, they're off doing things, but they're inevitably, if you frame the problem correctly, they can provide labels. So for example, let's take Gmail as an example. You've got email. Somebody at the very beginning of the Gmail thing had to decide, like, how do we prep the perfect responses given a particular scenarios? But eventually, once you kind of juice the system, you bootstrap it. Now there's like a set of categories, like somebody says something like, hey, you did a great job, and it's thanks, or like what, like there's canned responses.
Yeah.
Once you get to the canned responses, now the users of the system are giving you labeling. The question I have for you, though, is how does your approach both leverage an audience for a given product in the labeling process, and how do you leverage other humans who are like sort of more specifically building for models?
Yeah. So I will say this is an ideal we haven't quite achieved, but it maybe well summarizes how I think it should work.
Okay.
I don't believe in a labeling process. I think the fact that we think about an explicit labeling process is actually, I think it's problematic because there is that implicit division between, what we were doing at labeling and what we're training at that time and what we're trying to accomplish in the real world. And I think that's actually very, very tough on both sides, because I think that it kind of implies that it's sort of this, it's sort of like the CSV becomes this black boxy kind of handoff. And I think that's something that we found makes it very, very hard to lead to long-term success in problems like that. So I think that the way that we tend to frame it is we actually say the subject matter expert, right? What they're doing is not labeling data. What they're doing is teaching the machine, which is very, very different, I think, from the traditional framing. The traditional framing is like, okay, like you're figuring out the data, and then there's some like magic black box that is the data scientist that the data goes into, and then you get some like magic out the other side. So we say by like changing that paradigm really significantly, you actually have to give, we think, the non-technical person ownership over this data, how this data is being tagged, right? What is being extracted. The data scientist is there primarily in an architectural and advisory role, right? And we actually think that's where they can be really, really effective, is helping them be like, hey, these two fields, like I can't model what's going on. And the data scientist can be like, oh, like I'll like click through, oh, hey, you got some bad recall. Oh, hey, look, these two people are labeling it in totally different ways, like go fix it. So that's kind of like when we think about what is the happy loop cycle, that's actually much more what it looks like. And I think that we try to lean into this idea that you want to fit into the existing thing that is happening at the business. Like someone is processing these contracts today. So as much as possible, right, you want to fit into the way that they're processing contracts today. And sort of to your point earlier, you want to figure out how to fit into that cycle to get the natural, sort of supervision that they're doing anyway. But crossing that gap is not easy. Coming up with those categories in Gmail, maybe those auto responses aren't the best, but maybe, looking at the difference between those auto responses and that tab autocomplete that just gives you a couple of words. Mm-hmm. It's like very, very different kind of interaction.
You said something that I'm trying to unpack a little bit.
Yeah.
It sounded like you have some kind of dialogue that happens between data scientist and labeler, who I think you call them the non-technical person, but it's
subject matter expert.
Okay, so you're a subject matter expert. It sounds like they're operating in the enterprise with a particular thing they're trying to do. Like, I don't know, it's a fleet of lawyers somewhere, and there's a particular type of law that they practice, and a particular type, and they're labeling
whatever the data you're processing with the ML. That's the person that processes that data without the ML.
What does that dialogue look like? Like, how does the non-technical person find out about a given label's efficacy? I assume you're rendezvousing on efficacy, and the data scientist is somehow like telling them, I need more examples of this. I need less. I need
totally. Yeah.
Examples.
Exactly. Yeah. So you with these nice new transfer learning models, right? If you get the timing right, someone can just like label even a couple dozen examples and get this really powerful kind of live feedback from the model. And even if they're low confidence predictions at first, right? If you think about the UX very intentionally, you can present that in a really reasonable way to them. And I think what we found is like giving them that piloting ability, giving them that ability to even often just being like, hey, actually, these 3 labels actually totally wrong. It shouldn't be these 3 classes. It should be these 5 classes instead. And I think just really importantly, they're never going to get it right the first time. We found that like telling them to be like very intentional in the early days, like it doesn't help that much. It's just like how, and automatic model training is the way that we do it, and directly displaying these results to them in context as much as possible.
If you jump back a level, like, do you find yourselves having a hard time at before your customers are even knowing about your product, you have to kind of talk to them a little bit about what they're trying to achieve. And if you're interacting with data scientists, they've already filtered the problem into a language that's easy for other data scientists to understand. But if you're talking to these non-technical folks, you have to assess if the product's a fit. How do you do that?
We really push them for specificity. I think that's why we try to center the conversation around data as much as possible. And look, there's plenty of heuristics that we use, but 9 times out of 10, if someone is like, I understand that coming up with a consistent schema and like labeling this data for the outcome I want is my responsibility. Number one, they've got to like get in with that mentality, because if they don't believe that, if they think the AI is this like magical autonomous thing that's going to guess what they want, right? We just know they're not going to get to success. And then the second thing is making sure that they can actually put together 200 examples of this. And we think 200 is a really, really important piece, because like, look, if it is a useful example that you should be using ML on, that you've got real volume with, 200 should be a drop in a bucket, right? This should be the easiest thing on the planet. And if you can't actually process 200 in a consistent way, like we know this is not a real use case. We know like nobody actually cares about solving this, or it is not close enough to being solvable that someone can actually define the problem. And that's a huge, huge part of it.
So one of the challenges that you run across when you're defining a label space like this is category boundaries. And so, there's like very different approaches to labeling, so like a common approach is, which I suspect you're following, is, so you're doing this binary labeling approach, positive examples of the label and negatives. But there's also like kind of multi-labeling.
We do not actually. Yeah. So that's actually, we found 90% of everything is multi-label. That's my short answer to what you're saying.
So that's interesting, because that's what I say, and that's what business does. Is we do an awful lot of multi-labeling projects. Yes. So that's interesting.
I like multi-labels are default, like 100%. Even when the category boundaries are fuzzy in like 10% of the cases, it's just like having that additional power. It's just a better way of approaching those problems. I think there are exceptions, but they're few and far between.
It feels to me like one of the challenges with multi-label labeling, as you know, is you have to be able to wrap your head around the full label universe. Because if you don't label something, then the presumption is that it's not that thing. And the other challenge with multi-label labeling in this context is that you start labeling, and then, maybe label a few hundred, a few thousand things. Now you come up with a new label. In theory, you got to cycle back through and filter. How do you address that problem?
Yeah, so great on both those fronts. So I think that first, on understanding the universe of labels, I think that's a huge point. And I think actually that is a problem that you see in a lot of problems that people think are flat classification problems. And I think my major thought here is just like most classification problems are multi-label, I think that most classification problems are also hierarchical.
Well, you are like in a mind meld, because this is what
I just steal the words from you.
This is literally what we've been doing for the last few years. Is like,
yeah, I don't think you can reasonably think of more than a dozen labels at a time, frankly.
Yeah, and when you frame things hierarchically, one of the advantages as a labeler is you can be labeling really specific cases, and you don't and then you can later on you can rearrange the boundary definitions of parent categories.
And the other good thing when you're taking that multi-label approach at the same time, to your second piece of now when I've got a new category to add later on, actually it's not as bad. Like if I were trying to keep them as distinct categories, I'm just shit out of luck. I've got to start from scratch. Here, It's like, okay, I don't have to start from scratch. I have to find a couple of indicative examples. And then that's where you can have, some active learning stuff would actually like be like helpful to plug in a situation like that, right? Like find historic stuff in the corpus that probably also, we have mislabeled there.
Interesting. So like one of the challenges we have, and maybe you have the same challenge, is for certain problems, you mentioned like, hey, you get a couple of hundred examples, like life is dandy. But for some problems, particularly like visual ones, what we find is like not all labels are created equally in terms of the importance by a customer. And so you find that there's like some particular case that's like much more important, and then you really have to sort of naturally focus on it. And it can be very nuanced. It can be, a complex image scene, and there's like something really specific in there that like trying to like go after. And so one of the things that we found is that building multi-label models gets you a good chunk of the way there. It gives you a nice backstop, but we've actually started like layering on binary models on top, and actually even commingling the binary labeling universe with the multi-label labeling.
Yeah, I guess we really are mind melting, because that's exactly what I was going to say, right? Because I think that's exactly right. If you do really have this case that is super specific, and like in this region, a totally different set of rules applies, right? Like that's a different model. It's actually another case that I would say is very, very common. I would say even it might not be the case that you've got one edge case, but maybe there's like 5 or 10 actually really important edge cases, and you need specific metrics on those edge cases. It's why the cycle time and iteration speed is so important. Because I think that, very often the answer is, hey, we thought this was one model, but maybe by the time we're done and we've actually mapped out the whole process, this thing is 12 models.
It's funny that you and I are having this conversation, because I've never felt like anyone else in the ML universe really appreciates these two issues, right? Like almost everyone else that I know of is in binary labeling mode, and they're in like heavy kind of active learning driven mode in binary labeling mode.
It's sense. Because it's so much easier, right?
Yes, it is. And it's easier to define categories that way.
And define your efficacy metrics most critically, right? Because the second you're outside of binary categorization, right, like the question of what I'm even optimizing is suddenly like tremendously non-trivial. So people try to make things fit into that mold very much.
Yeah, but one of the things, and I think we're probably in the same ballpark, one of the things that we find customers very often just need one or two or even a handful of models built. It's usually like hundreds or many hundreds of models.
Yeah.
And when you're wrapping your head around how to label that, like you wind up in this multi-label universe pretty fast. The other thing that I think we have in common is like, so you've got these SMEs. So these are people who actually can wrap their head around the problem. Exactly. In our case, we actually just hire like bright college kids because we can't rely on.
We do have an internal team as well, maybe to be clear, but that's actually another place where we depart kind of, I think, very much from a traditional model, but it sounds like y'all maybe do a similar thing, which is think about these as random third-party contractors, right? That are like going to come and go and like pick up a project and leave it down. Like, no, these are experts, right? These are people that are like very, very good at what they do and need to be picking up new tasks quickly. And I think that for a lot of people, like it's a compelling job in a lot of ways. I wish that people considered, that kind of work more often as full-time employment internally, because we've just seen such a tremendous benefit.
Yeah, I know. Like we get asked the question a lot, like, well, why don't you just use Mechanical Turk for your labeling? And it's like, well, look, if we get to the point where we understand the problem well enough to Turk it, then yes, of course, we will. But usually there's a few other reasons why we can't. Security is one, like it's just
and frankly, like usually by the time you understand it well enough to Turk it,
you don't need
enough data. You don't need to do it. Right. Exactly.
Yeah. That's exactly right. And meanwhile, you have like all of these annotation companies that have the most bizarre pitches, which have always surprised me. They're like, hey, I need 100,000 things labeled, which is like the wrong thing to ask for. And then somebody else is like, oh, well, I'll charge you X amount per label, which is like the wrong way to price something, because now you're incentivized for quantity, not quality. And on the first case, you're presuming that the 100,000 is going to cover the distribution of what you're trying to actually label.
It's something that's made me scratch my head for the longest time, because you're right. Like it's a huge trend. And I think it is largely just a symptom of ML teams having just stupid amounts of money. And I think it's this idea, which is not totally wrong, but also not totally right, that no matter what they do, if they're not really sure on what the next step is, then investing in data is a safe bet. So I don't know what the next architecture is, but if I buy 10 times more data, right, I know I will see a model improvement. So I think that that's a lot of the ethos
Yeah.
on the one side, and I think that's what props a lot of the companies up on the other side. I really question how much longer a model like that is going to last. I think when you look at the really high-performing organizations, places like Tesla, I think looking at how much of an ownership and how a unique process they have put around their labeling and their unique flavor of human-driven active learning, right? I think you're going to see more of that, because I think people are really starting to realize, data is not this fungible, like one size fits all, like I get it and that's good, like thank you black box kind of interaction. Like it is this very holistic, organic kind of thing.
Also, I mean, I think there's a sociological element, right? Like as a graduate student and doing anything that involves some machine learning, I mean, maybe less so now that other disciplines are getting into it, but like the traditionally technical disciplines, you're rewarded on algorithmic improvements. Like nobody's rewarded by like going out and finding better training data. Like they're rewarded because they came up with a new network architecture or some kind of interesting insight. And so when they go out into the working world, they carry that mindset, and training data is a burden. It's not a thing to move the needle. It's just this annoying thing you get stuck with. And so they want to
or it's what you have at the start of the process.
Yeah,
it's the CSV you got from your professor, right?
Yes, and like it's fixed, it's presumed fixed, or it's like it's like a NIST standard, and it's a specific corpora or whatever, and everybody's competing on it. All of that basically, when you're out practically building models, like I say this a lot to customers, where it's like, look, if you have a choice between spending an hour getting more training data or like a day tweaking your models, take the former, because you're going to see more impact or better, or something around the data.
I think it was something. I want to say this was Richard Socher, but it might have been some other researcher. So I apologize if I'm mangling that. It's like if I had 24 hours to build a model, I would use 23 of them labeling data and 1 hour building them. I'm like, yes, absolutely.
Isn't that, I know it's funny because like it's just not the way people think, I'll
tell you the craziest thing is it's this weird kind of like aversion to touching data. And like, I don't know if this is quite right, but it's almost people feel like it is beneath them. And it's something that I've always found really strange and very curious. And I'll tell you something kind of funny is that there was this one company and they had a bunch of survey responses that they wanted to analyze. And they were looking to pay, 6 figures to have someone analyze all these survey responses. You want to know how many there were? Less than 300, right? I was like, these are like a paragraph. And the second I got them, because I assume, this is like 100,000 responses or something ridiculous. I'm just like, well, has he considered reading them?
It's funny that you bring this up. A little side note, hopefully nobody I interview is listening to this, but one of the questions I asked is like this whole thing about like rewind 15 years ago, pre-Google image search, like basically build one of these from scratch. And part of the setup is like somebody just gives you a drive with with 100,000 images in it, and all is they're numbered 1 to 100,000 JPEG. Hardly ever does anyone say, well, I'm going to open up the images and like just scan them and look at them. I mean, like 100,000 is not that much.
Yeah.
Look at like a sample.
And the thing is, like, that is exactly what you should do, right?
It's just
like, people will literally spend years of their life trying weird statistical tricks to avoid spending 10 minutes opening the images.
I know, it's absolutely bizarre. Need help with computer vision, natural language processing, automated content creation, conversational understanding, time series forecasting, customer behavior analytics? Reach out to us at xionyx.com. That's XYONIX.com. Maybe we can help. So I want to go back to change the topic just slightly. On your site, there's a lot of talk about RPA and BPA, like this process automation world. Are those like some clients that for whatever reason are really attracted to your platform? And tell me a little bit about like why, like what are they trying to do and where do they get stuck, and how does your platform kind of help them out?
Yeah, so I would call them more ancillary technologies. These are, very strong, rich partnerships for us. I think specifically looking at automation writ large, there's been this really big explosion of RPA, and I think really what I would characterize as the structured side of automation. Right.
But just for the sake of our audience, can you just explain what RPA is?
Yes, I can.
Yeah.
RPA stands for robotic process automation. The best analogy I can use for someone who's a little bit technical is it's basically Selenium with flow-based programming attached, which is to say that it's very good for things like open this window, click that, copy this value, paste it in here, right? Where you've got this very, very procedural kind of a flow.
You've got these office workers that are like doing something over and over, like maybe preparing a particular tax report. You got 100 accountants and they're all like going in here, opening this thing, closing this thing, transforming this thing, doing like stuff, and now you can sort of script that at the window level or something.
Yeah, and I think a lot of developers don't understand how much work inside the enterprise that describes.
No, because we would never do anything this way, right? Like
right, exactly. It's
never think to automate this stuff because they're like, good Lord, why would you even use a UI?
Right, exactly. This is stuff like I have to copy and paste all of these values, from this email into this Excel sheet, and it takes me 10 hours, and I do this every week. And by the way, we've been doing this for 20 years, riddled throughout the enterprise. And that's what RPA is really, really good at. And I think the specific way that RPA plugs in that's kind of, I think, clever is, like you said, usually if you could fix these architecturally, it would be really simple. But RPA does everything on this UI level, right? On this kind of click, like see what's on the screen level, because in a lot of cases, these APIs are very difficult to access, or maybe IT is super overburdened, right? Or maybe the guy that built that system, quit 2 years ago or something like that. Right?
Yeah, or you just need different people, right? Like you could write an RPA process as just being the person who clicks and opens and closes and does the thing, as opposed to going off and talking to somebody who knows how to interact with some 1990 something soap interface.
It's the speed also, right? It's just like, you get it done so quickly. You don't have to deal with, 6 months of bureaucracy and getting your requests put in the queue. And a lot of these use cases, they're small enough that, when your standard size an IT project is going to be, 7 figures in time and salaries and like how are you going to make time to like solve you the 10 hours every week? And, RPA is really meant to fit into folks that are not usually able to code up automation on their own and make that more accessible.
If I have to guess, let me just try to guess. I might be totally wrong, but let me try to guess where you're
probably not
stuck. So the customers are like looking at this thing and they're scripting something, and somehow they wind up in a window that they need, like based on a particular value in there or a particular sequence of words or something. That's what routes them to make the next step. And so they need to like stop and maybe make a model to extract that thing so that they can get to the next step. Is that?
That's that's a very good start. And that is initially how we thought about it too. And I think that's how a lot of people think about it, is like, you might think initially, okay, I've got some process end to end, and one block in that process is do the invoice, like get the values out, right?
And there's a PDF or whatever.
Yeah. So something along those lines. And that's not, and sort of like I said earlier, it's not totally wrong, but it's not totally right either. And I think the place where we have been most surprised is that actually when you look at just the process of whatever the like unstructured document is itself, it turns out that actually usually has its own internal process unto itself. And the thing that's really interesting is often you're thinking like, oh, these might be coming in email attachments, right? This might actually be some completely parallel path. I was very surprised. In the early days, I think we expected 80-90% of our use cases were going to be exactly like you laid out, right? Like RPA in, like gets the document, passes it to us, like we do something, passing back the payload back into RPA, off to the races. That's probably 30% of what we see.
Okay.
Actually, 70% we see is actually the unstructured use case, right? The invoice processing, or it makes more sense if you think about things like contracts, right? Where you have this much more complex notion and system, are just systems unto themselves that actually stand totally alone, but they are the same kind of companies that are interested in this automation. And I think for more of them, they hope that turning this into kind of one consistent automation fabric in the future would be really helpful. But we see actually a division now. There's like structured folks and unstructured.
I don't know. I'm imagining like a fleet of accountants generating tax returns, and somewhere in there's a massive database of receipts, and they want to just, and somebody's like, oh, we got the receipts. We should know like the amount and the company and the type of company, and like maybe we can use this thing that the RPA guys are using, or
like so that's decent. Let me maybe give a slightly better one that might make it a little clearer, because I think that the problem just with invoices and receipts is that they are definitely on the simpler side of things, right? I think that on the one hand, right, if you talk to folks that are used to the form side of the world, like invoices and receipts are like the high end of complexity, but in terms of the things that we deal with, invoices and receipts are kind of the simplest, or like there's a little bit of ambiguity. But if you think instead of something like a mortgage,
Okay.
and someone has to process your package of mortgage documents, and there's like 30 different things in there, 400 pages of stuff. There's like, I've got to extract these values here, and then I've got to compare them against this, right? And then I've got to do this business logic. And it turns out that a lot of those operations, a lot of that, oh, compare this to this and extract this, and you've got to sequence this before that, and I need human review over here and not over there. We thought that RPA would be able to handle a lot of that, but it turns out that unstructured workflows are just really weird. And so a lot of the traditional tools that you might think of in RPA just don't map really well to those kinds of highly unstructured workflows. So I think we find by and large, folks do them in parallel, and then they tend to multiply in terms of benefits to the organization. Maybe this person used to have 40 hours a week, 10 hours now is handled by their RPA bots, right? And like 20 hours now is handled by their Indico bots, right? And maybe there's like a really nice 5 hours that is right at the juncture too, or something like that.
Okay.
Yeah, which very, very unintuitive. Like we did not expect it, but I think a lot of it is the complexity of these unstructured flows and these document flows is just much, much higher than folks expect. It's not classification. Classification sometimes happens, but it's kind of like a rare and more simple. Like extraction even is one of the simpler things we deal with, which is I think in ML schemes, custom named entity recognition on small data that's a tricky problem. But even that I think we would characterize as an easier problem than kind of complex multi-stage reasoning over a 200.
I can imagine a lot of nuance here. I mean, this is kind of the challenge with how this RPA stuff is evolving in many ways. It's like, okay, I can automate this piece, and then I get stuck, and now I got this bridge to cross, and I got to get this other piece. And so then maybe you set up the RPA piece to just fill up a queue with that place that you get stuck, and then you walk down, you get across the bridge, and then now you RPA a little bit more.
In some cases, that works really well. I think though what RPA has done that's really amazing for us, right, is they've just triggered this whole mental thought around automation. People are hungry for it, and I think it is clear on the one hand that RPA has kind of stoked this appetite that they can't fulfill. People clearly have this desire for automation well beyond what RPA can provide. And you see all of these industries now popping up that can provide pieces of this, right? I mean, task mining, I think, was another one that started off completely as like almost a subsection of RPA, now is its own separate enterprise.
You said something at the very beginning when we were chatting about the value that your system brings in monitoring like models once they're deployed. And these kinds of workflows must get very awkward to debug. And you must get some weird bugs in there, like a lot of them at once, because somebody ships a new version of software and the look and feel changes. And like your visual imagery, like whatever that model was, might not yet have like learned this new transparent look or whatever that got rolled out. And now all your clients who had that sort of piece suddenly break. Do you get anything like that? Or
we have to work very, very, very hard not to. The magic of Indico is I can say no, right? You actually don't have that problem. We have totally addressed that. It was really hard.
I don't see how you could address it. Like, I mean, unless you're like artificially contorting your imagery so that you can create like fake data to like guess how things are going to change or something. But
so there is, I guess there are some elements there of just being robust, but it's actually it's different than the point, because I appreciate, because that should be your reaction. That was kind of one of our sayings in the early days is if you believe what we're saying, then you're not paying close attention. And so a lot of what it comes down to is like you have to really change your mind about what production looks like and what production is defined by. And that's really the key, because you're correct. If you use these two assumptions that I think a lot of people bring to the problem, you will never solve this problem. Number one, if you think that learning happens in a closed loop, which is like I have to be able to learn from each new incremental example, and as is, you won't be able to solve this problem.
Oh, I think I get where you're going. Okay.
Yeah, and then the second thing is also, if you go to the other side and believe that your model is totally static, you will also never solve this problem, right? Because you don't have any recourse.
So the people, let me just guess, that are building the flows, the process flows, they're also your SMEs. They're also sort of the ones who are providing the training data, they're like never actually out of the loop. Like they're sort
Not
of like
completely.
because they always have to spot check for you and they have to always help in the monitoring. And
Right.
so they're going to be the ones to actually flag the problem in the first place. And so they're going to be the ones to give you a few more examples, model gets shipped, and then boom, it sort of starts feeling seamless. So you don't get
Exactly.
blindsided.
Right. So you never turn it all the way off. You maintain this thing at all times, which is just like this is a knob. And this knob, it's going to turn up and it's going to turn down, but it's going to turn up and down, naturally over time. And then the other thing that turns out being really important, 80% of all production errors can be traced directly back to bad training data. 80%. Now, obviously, that's like rough. I can't say that in like all cases, but I don't think anyone is surprised by that. So the other piece that ends up being really, really critical is we built all of this explainability around interrogating, like you can see any error that comes through the system, trace back to what training data is the model relying on to make this decision.
Oh, yeah. And what are you using there? Are you like leveraging like SHAP and some of those kinds of techniques, or
our own stuff that we built before them and works better? But very, very roughly, the strategy is it all comes down to prediction attribution. So I think we do have, some of those more traditional tools, right? Things like saliency maps, like those are definitely useful, but I think useful in a different way. For us, really what it comes down to 100% is like, I need to be able to find the bad training data. So we're almost like we gear everything around that.
This is what machine learning has been for 20, 30, 40 years, is like
totally
through training data, finding out like, we're missing this, we need more of that. And you're just kind of like building it into the workflow, which is super powerful.
Combining it with the transfer learning stuff and those modern techniques, just because when you're doing that on when you're doing that on 100,000 examples, like you need a team to figure that out. That is like almost impossible. On 200 examples even, right? It's very, very challenging. But at 200 examples, like it's possible, like you can go through that, you can interrogate that and attribute in a really meaningful way.
I would love to talk about even just the part of the prediction attribution, that we could go on for hours, but we're running out of time. This has been a fascinating conversation. I'm going to just ask you one final question, at least for this episode. Maybe we'll talk more on the other topics. 10 years have passed. What you're aspiring to do has happened. Whatever levels of success you and your team can bring to bear. What's different in the world? Like, how is the world better off, and what does it look like?
I'll answer that first to society, and then I'll give maybe a more specific AI answer. Right. So I think one of the things that's always been very shocking to us at Indico, working in so many of these mission critical document use cases, and I don't mean to, say that's the only thing we do. It's just, very relatable and a very hot.
No, I get it.
You can have people doing the same process next to each other for 30 years. They will not realize that they have been doing it differently. These errors compound, right? And the things that we're talking about, these are not insignificant applications. These are mortgages. These are loan approvals, right? These are health insurance. And the first thing that we always do when we see the inconsistent state of the data, right, is it used to be in the early days that we were just so incredibly shocked. How can something so important have such insufficient tooling around it? But, like we just didn't think about it. These are things where people have been doing this in the same way for 30, 40 years. And I think that a lot of the problems that we see today in terms of, differential outcomes, right, and how kind of non-transparent a lot of the most important processes today, even if you think about things like court documents and legislation and the transparency there. I think that I would really like Indico to have a serious and meaningful approach there. I want us to look at the idea that we would have people just decide in a black box whether a loan is like okay or not. I want us to be a little horrified at that idea that that's how we used to do things, that there was no transparency, that you didn't have this layer of explainability on top.
That's all for this episode of your AI Injection. As always, thank you so much for tuning in. If you enjoyed this episode on using AI to extract insights from unstructured enterprise data, please feel free to tell your friends about us, give us a review, and check out our past episodes at podcast.xionyx.com. That's podcast.xyonix.com.